Alrighty then. Class.
Yes.
I heard you there. I heard you.
You want us to remember it though?
No, I heard you. You did. All right, so you guys, we're going to take a look at the graph of the derivative of the function. So first, looking at the blue one. The blue one is the function, the green one is the derivative of the function. So let's take a look at a couple things right here. So x and y values are going to be important when I'm talking about this. So let's take a look at, let's go right here at 2. Okay, the y value at 2 is down here, isn't it? Say yes. Yeah, okay. And look at the y value here. So the blue function, if I draw a tangent line, there it is. What can you tell me about the slope of the tangent line there? The tangent line, it is going to be a line. The tangent line is always going to be a line. It's positive, right? Okay. And so now if I take a look at the derivative, and this right here, the derivative, isn't the derivative at this coordinate right here when x is -1? The y looks like, what's that, like +3, +4, something like that?
Positive 3.
Think so?
That's what
3, yeah. There we go, +3. So that means that the slope, so when x is -1, the slope is +3. Yes? And that's the slope of my tangent line. Okay, let's go to 0, 0. Now, the tangent at 0 of my function, is that horizontal line? Say yes.
That's a tangent.
2, 2. Yes. So, right here at this point, what do you think the slope on this function is right here? Okay, the slope is 0, right? Slope is going to be 0, so therefore, this coordinate on the derivative function is going to be 0, 0. So what that means is, when my x is 0, my slope is 0. Okay? So now, if I'm looking at every single y value on the green line, every single y value on the green line, what can you tell me about every single y value on the green line? Yep. They're all positive. Very good. Good job. So they're all positive, right? So if all those are positive, even though it goes down to 0, they're all positive. So what do you think that's going to tell me about my function? No. Think about it. If my y values of my derivative is always positive, what do you think about the slopes of all my function? Negative. Let's look. Is the slope here going to be negative? No. Is the slope over here going to be negative? Is the slope over here? Right there? No, because these are all my tangents. I just can't draw a line very well. So, all these slopes of my function, so my function is always going to be positive, isn't it? So, right here, even down here in the negatives, if I plug in my number, my slope, think of the roller coaster, okay? Think of a roller coaster. Is my slope always going up? Yeah, look, it's always going up. It's going up, 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 up. It levels out, right? Down to 0, and then it goes up, up, up again, right? So what that means is that it's increasing. My slope is increasing over my entire interval. Does that make sense or nonsense? Okay? And so that means that my y values all right here. These are all positive. The y values are all positive, right? Yes, positive y's. And then going this way, again, all positive y's. Hopefully that makes better sense. Yes? No? Maybe? Crazy. Crazy. All right, so when we start going through and practicing with this, again, on the next slide here, you can see, look, there is a slope of 3. There's a slope of 12. There's a slope of 0. A slope of 12. So over here, -2, my slope was 12, so the y value over here is 12. Over here, at -1, okay, -1, my slope is 3, and the y value over here is 3. My slope is 0 at 0, and the y value over here is 0. At 2, right here, my slope is 12, the y value is 12. You guys see the correlation in between this? Hopefully? Looking at me crazy? Okay, yeah. Don't worry, because I'm throwing some brand new voodoo at you that you have never seen before. That has not been in any of your other, even if you took physics, any of your other classes you've ever had. So this should be something brand new. Like your brain just got a wrinkle right there just by learning that. That's a medical thing. Supposedly your brain, creates wrinkles as it gets smarter.
Yeah.
Supposedly. All right. So now let's see if we can do this one. Here is the function. So the blue line's a function. I want to try and figure out what the, like this horrible green. Oh, wow, that's horrible. Now, important places. In this curve right here, this thing would be a what? Yeah, it could be a local max. It's not an actual max. Why would it not be an actual max? Because it goes on to infinity, right? Okay, so at this, that's important. So when you're looking at this, I want to look at my local min and local max. So local min, local max. So right here, so as my roller coaster, think about it as a roller coaster. Right here, what do you think is going to happen to my roller coaster? The slope goes to 0, right? So on the roller coaster, it gets up to the top, so the slope is 0, right? So if right here, the slope is going to be 0, that means that the graph of the derivative is going to be right here. So at -2, my slope is 0. Yes? Okay, good. So that's good for my local maximum. What about my local minimum? My local minimum is down here. So again, roller coaster, and down over here, what's going to happen? Slope is going to be 0 because it's changing directions, right? You're going from a downward and it's going back up, right? So right here, the slope should be 0. So that is going to be right about here. 3/2 is right there. Slope is 0. Yes? Okay, that's important. So now, what do you think the degree of the blue line is? What's the degree of that function? Look at the shape. Look at the shape. What does that tell you it's going to be? The shape. take a look. What shape is this?
Parabola.
Parabola? What's the degree?
2.
2. This is x squared, right? Yeah? Okay. And so, what do you think this one's going to be?
3.
3. It is going to be 3. That you could do that too, right? But sometimes when you have a bounce, it's not the same. And if you have a non-real zero, you also have to pay attention to that. So non-real zeros would be if you, but yeah, that is one way to look at it. So if you had something like this, okay, so your degree is still 3, but if you're trying to count zeros, you would only have 1. Okay, but yes, that is, the degree is 3 here. Okay, so degree is 3. So if it's a third degree, I'm going to just say x cubed. So if this is my f of x, what is going to be the degree of f prime of x? X squared, right? It would be 3x squared, wouldn't it? So the degree would be, it's a second degree. That's important. Wow, that doesn't even come up. That one's horrible. So it's a second degree. So my derivative is going to be a second degree. So what shape is that supposed to be?
Parabola.
That's going to be a parabola, right? So now let's take a look at my parabola. So if I have a 0 here and a 0 here, now we got to try and figure out what's going to happen in between those two. So is it going to be a concave up or is it concave down? Concave up. Let's take a look. Let's look at the slopes, okay? So I'm just going to do it piece by piece now. Do this color. Ah, yeah. That's pretty close. Actually, too close. There we go. All right. So from here to here, I'm on the roller coaster. Roller coaster. What do you think's happening from here to here? You're going up, right? So what does that tell me about my slope? My slope is positive. So that means from over here, from -4 to -2, all that is going to be positive. So if I was to graph that, what would that look like over here on my derivative function? If it's positive, that means is it going to be above the x-axis or is it going to be below the x-axis? Where's the positive numbers?
Above.
Above. So it's going to go like this. There you go. It's going to look like this. Does that make sense? Okay. So that's important. Now let's look at the right side. We're going to look at the right side. So going for the right side, let's go from over here. I'm on the roller coaster again. I'm on the roller coaster, okay? And we ride the roller coaster from left to right. So going from left to right. What is this from 3/2 over to the right? It's going up, isn't it? So your roller coaster is going up, so that means that right here, my derivative, the graph of the derivative has to also be going up. That means right here, this is also going up, isn't it? Okay? So now between those two, what's happening between those two? Get this ugly color? Right. All right, so from here to here, I'm on the roller coaster. What do you know about the slope on that roller coaster right there? No, I want Danny to.
Okay.
You're on that roller coaster, Danny. Is that a fun ride? Okay, so in between -2 and 3/2, what is that roller coaster doing? It's going down, right? So all that is going to be negative, isn't it? So all that is negative. So from right here, I look, and this all should be negative in between here. So right here, it is going down, 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 down to here. So all those are negative, so that everything here in between should be down here somewhere. Right? It should be down here somewhere. So all those values, so I'm going to have something that's going to look like this here, right? I'm going to have something in between there. So my graph is going to look something like a parabola when I'm done there. Yeah? Okay. So let's go through and try and figure out where that's going to end up at. So if I'm looking at this, all this is negative here. Okay? So it is going down, down, down. I'm going to end up having a vertex at 0, but I don't know what the y value is going to be at 0. I don't have a function. I don't have a function for that one. But it is going to be somewhere down here. So because of this, I could look, okay, so now from here to here, it's going down. Okay, it's at least going down 3, isn't it?
Yeah.
Okay, it's going down 3 over 2, so it's going to give me something like this right about. So for it to be, so that is, let me see, -2, comma, three halves. And so in between those two, it would be -6 halves and 3 halves, which is 9 halves, 9/4. So at 9/4, so it should be my distance. So all I did is I took the distance from here to here,
Oh,
and I'm dividing it by 2.
you get the midpoint?
Yeah, I'm trying to get the midpoint,
Okay.
and that's where I get with that. So from there to there, so that is 3/2, and here, so from there to there, that is -2.
That's pretty fun.
Oh, I screwed this up because this should be a -4 over 2 and 3 over 2. So that's going to give me 7. Yeah, 7. Distance is 7. 4. So 8 over 4 and plus 7 over 4, which is -1/4. So for my vertices in between there and there, I'm going to end up with -1/4 right about here. here. So -1/4 is going to be the vertice of this.
I thought you could just,
I don't have the degree, or I don't actually have the real function. I can figure out what the function is, but I'm just trying to sketch this now by looking at every key item. So I could have just sketched it and just set it and took my parabola down to here and just say, oh yeah, it's going to be that. But I just want to at least find where it's going to be, because otherwise I don't like it being ununiform. I really don't. Even though that my graph is horrible,
ish
symmetrical-ish.
to some degree.
There you go. So let's see. So in between, like there. Something like this. We're gonna end up playing with these a lot later on with graphs and derivatives to see what the slopes are as we're going through here.
Okay.
There you go. Wait. There you go. Okay. Identify where a function has no derivative. Piecewise derivative here. Determine if f prime of 1 exists. Now, so let's go ahead and take a look at, I want to look at here. So right here on this piece, if I plug in 1 for this, so that's going to be a -2, 1 squared plus 4 is going to give me a 2. Yes? Good. And then do it again. So 1 for the other side, squared plus 1 is going to give me, what's that give me? That give me 2? Does it give me 2? Say yes. Okay, good. It gives me 2. So what does that tell me about this graph? When we were talking about continuity, the left side and the right side,
Must be meeting at the same point.
are they meeting at the same point?
That's what's continuous.
So that makes this one right here is continuous. That's good. So now that we know it's continuous, there. So if I were to sketch a graph, which looks like this. So the top portion, let me change to blue here to make this look better. The top portion here so both of them meeting at the same point, right? So there's the top one, and the bottom one is here. They are continuous, right? They are continuous, but because of this, how they meet is important. Can you tell me the slope at that point? The pointy point right there. Right there, where they connect.
The slope 0.
Nope. Not 0, even worse. It's almost like undefined. You'll see in a second. All right, the slope does not exist.
Okay.
Look at the tip of your pencil, okay? So the tip of your pencil. Can you figure out the slope at the tip of your pencil? The very tip. So if I was going to do a tangent on the pencil, it's always going to be like this, right? So you can't really balance it on the tip. Yes? No? Maybe? You're balancing something on the tip of your pencil. And what your finger that you're balancing on that is the tangent line. So the slope of the tangent line, isn't that going to rock up and down?
Yeah.
Yeah, so it doesn't sit on there very well, does it? So what this is called, it's called a corner or a pointy point. You cannot get a slope at a corner. You cannot get a slope at a corner or a pointy point. So we said that it's continuous. It's continuous, but where those two come together, it has to go continuously and it has to flow together. Think if you're on a roller coaster. Will that roller coaster work out?
No.
Nope, because the slope has to go up to 0 first, doesn't it? Slope has to go down to 0. If you're on that roller coaster, it'd be boom, right there. Okay? That would end your roller coaster fun.
What's up in the back?
No, because you're still not going to help. Does that make sense or is that nonsense? Kind of nonsense?
Makes sense.
Kind of sense? Danny? So, before we get too far into this, I'm going to stop right here. I'm going to stop right here. We have 2, 3, and then some graphs. So, I'm going to pick these up on Monday right here. So, make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from the merch store.